I just want to talk about the second one real quick.
Go
because
for it.
The second one is even cooler,
Go
okay?
for it.
So the second one is called the light box, or I think it's Einstein's light box, okay? And this was his argument. He says, okay, you have a box that is, you're able to suspend it on a spring, and from there you can tell the mass of the box, or however you want to tell the mass of the box. The point is, you have a device inside of the box that can produce a photon, and you also have a clock in the box that is exactly timed to a clock that is outside the box. And so, if you look at your clock that's outside of the box, it says the exact time. That's okay, you get it. So, now, here's what Einstein said. He says, we open a small slit in the box, we release a photon, and then we close that slit. Now, when we open the slit, we have, like, the slit is connected to the clock that is inside the box. And so as soon as you open the slit, you know exactly at what time that the slit opened, and you can also tell on your clock because they're synced. Okay, so you know exactly when the photon left, and then after the photon leaves, what you do is you weigh the box, or you see how much does it weigh now that the photon left. And so the argument here is E equals mc squared. You can plug in the value for mass, and you can tell the exact amount of energy that is now in the box, I guess. And so you know the time, you know the energy perfectly well. There is no uncertainty here. So how do you explain that? How do you say, well, actually, no, there isn't uncertainty? Well, it turns out it took Niels Bohr a very long night, okay?
One night.
Thinking.
One night.
Yeah, this was during the Slovak conference. I think in 1930. Might be the 26th one, but I think it's the 1931. The 1930, that one, not 1931. Anyways. So, here is the argument, okay, to support the uncertainty principle. And this is actually quite a physical diss, okay? And here's why. This is probably the most beautiful rebuttal ever. But here's what he says, okay? So, everything's perfectly fine. The clocks are timed together. You're able to measure when the photon leaves and all that stuff, okay? And you're also able to measure the mass of the box. But remember how I said, to be able to weigh the box, you need something to weigh it, okay? No matter how you choose to weigh it, it's going to work out the exact same way, but in this case, we'll use a spring, okay? So you let a photon out of the box. Now the spring has compressed a little bit, which means that the box is suspended a little bit higher off of the ground. And so now, everything's perfectly fine. You can measure the mass, and you can measure the time on your clock.
Wait,
at which the photon left.
Since the spring compressed, wouldn't it have gone lower to the ground?
Well, the spring is attached to
because it's on
like
the top,
a frame.
Right?
Yeah. The spring is attached to a frame, so the box would
Okay.
Okay. But here's the most beautiful rebuttal. He says, Bohr says, according to the theory of general relativity, time passes at different speeds when you experience different amounts of gravitational influence. Okay? Which means I'm getting too excited right now.
This is crazy.
This is the craziest argument. He says, which means when you release the photon from the box, the clock that's inside the box is now a little bit higher up in the gravitational field of the Earth. Which means that now your two clocks are out of sync. Which means that the time that's on the clock inside the box is different from the time of the clock that's outside of the box, which means that you actually do not know when the photon left the box.
Oh!
Hence,
he uses his own argument. It's
The
crazy.
uncertainty
It's
principle
crazy.
holds. The uncertainty principle holds. Always.
That's nuts.
Einstein said, here's a situation. Bohr said, I will use your own theory
That's
to
the diss.
disprove your idea.
That's the thing.
That
He
is
used his
the most
own
incredible
theory
diss ever.
to prove him. That's amazing.